In this video, we're going to take a look at how to balance chemical equations. By the end of this video, you should be able to write a balanced chemical equation, and you should also be able to explain how the law of conservation of mass is used in helping us to balance these chemical equations. So as a review, the law of conservation of mass basically tells us that mass cannot be created or destroyed. In other words, it must be conserved. One way of thinking about this in terms of chemical reactions is to think about it in terms of the number of atoms. If I start with one atom of magnesium, like we do in this reaction, I must end with one atom of magnesium as well. Same goes for chlorine. Here we can see I start with 2 atoms of chlorine, and when my reaction has finished, I end with 2 chlorine atoms. This tells me then that mass is being conserved. I'm not creating or destroying my matter. I'm just simply changing its form. So in equations like that, everything works out okay and we obey the law of conservation of mass. But take a look at this equation. Here, we start with 2 atoms of hydrogen, and we end with 2 atoms of hydrogen. But unfortunately, we start with 2 atoms of oxygen and end up with only 1. So in this instance, we're not obeying the law of conservation of mass because it appears as though we're destroying an atom of oxygen. So in order to make my equation look like I'm obeying the law of conservation of mass, which this reaction will do, we add coefficients. Remember, coefficients are those numbers that are placed out in front of our symbols, and they tell us how many molecules of that substance we have. So if I need to make sure then that I have 2 atoms of oxygen over here, I would need to include a coefficient out front so that I have 2 atoms on both sides. And I would do that by placing a 2 in the front. Now I have 2 atoms of oxygen here, and on my product side I also have 2 atoms of oxygen. However, I messed up my atoms of hydrogen because now I have 4 atoms over here. To fix that, I would need to add a 2 over here as well. Now my chemical equation obeys the law of conservation of mass, and we say this is a balanced chemical equation. A very important hint down here is to remember that when we balance chemical equations, we can only change the coefficients. You cannot change the subscripts. So for example, I could have not just added a subscript of 2 down here to balance my chemical equation, because changing the subscripts changes the substance that we are referring to. So, some helpful hints to use when balancing chemical equations. If you're given a sentence or a word equation, make sure that you write your formulas correctly. If your formulas are not written correctly, you will either not be able to balance it or not be able to balance it correctly. And a lot of times when you get stuck and things aren't working out, this is an excellent place to check to see if you've made an error in the formulas. Always remember to add those coefficients, never the subscripts. Some reactions that have lots of oxygens and hydrogens are easiest if you balance those 2 last, so save them till the end. Also remember that if a coefficient is 1, we never write it. Just like we don't write 1 subscripts, we don't write 1 coefficients either. And then finally, always make sure that your coefficients are in the lowest possible ratio. So in this example here, we have a 4 to 2 to 4 ratio, which I could reduce down to a 2 atoms of lithium to 1 molecule of chlorine, giving us 2 formula units of lithium chloride. The second one here would be the correct equation because it's in the lowest ratio, and so always make sure you reduce your coefficients if possible. So now that we know the rules, let's take a look at a couple of example problems. In this first example here, we're reacting magnesium metal with oxygen gas to form magnesium oxide. To balance this, I start by doing my atom inventory. I see that I have 1 atom of magnesium on the reactant side and 1 on the product side, so that's good, that's balanced. But I have 2 atoms of oxygen on the reactant side and only 1 on the product side. To balance this, I would need to place a 2 in front of magnesium oxide. This now gives me 2 and 2. But by placing that there, I've now messed up my magnesium, so I need to go back and fix those. So 1 atom of magnesium to 2 atoms of magnesium on the product side. To balance those out, we put a 2 in front of magnesium. Try the next one on your own. In this one, we should have seen that it's already balanced. We have 1 atom of lead on both the reactant and product side, and we have 2 atoms of oxygen on both the reactant and product side. In this example, we would not need to add any coefficients because it's already balanced. Try the next one. To balance this equation, we see we have 1 aluminum atom on the reactant side and 2 on the product side. So to balance those out, we place a 2 up front. To balance my sulfurs, we see we have 1 on the reactant side and 3 on the product side, so we add a coefficient of 3 in front of sulfur. And now we have a balanced chemical equation. Finally, take a moment to balance the last one. Alright, if we take a look here, we can start by balancing aluminums. In aluminums, we have 1 aluminum on the reactant side and 1 on the product side, so that's balanced. If we take a look, we have 1 chlorine on the reactant side and 3 on the product side. So to balance that out, I would place a 3 in front of HCl. Now I'm going to try to balance my hydrogens, in which case I realize I have 3 on the reactant side and 2 on the hydrogen side, on the product side. To balance this, I'm going to need to get 6 hydrogens on both sides. To get 6 here, I need to erase my 3 and make it a 6. And to get 6 on my product side, I would need to add a 3 because 3 times 2 gets me 6. Now I need to go back and check my chlorines because I've messed those up. So to balance my chlorines, I see I have 6 here. So to get 6 on this side, I would need to add a 2 out front. 2 times 3 gets me 6. And now I've also messed up my aluminum. So to go back and fix those, I need 2 on both sides. So I would place a 2 out front. Doing my one last check, I have a ratio of 2 to 6 to 2 to 3. I cannot reduce those all by the same number, so this is the simplest ratio. And that is how you balance chemical equations.